everyone. Today we will talk about statistics, week 1 and week 2, and let's just get straight into it. What is statistics? Statistics is the branch of mathematics that helps us summarize, analyze, and interpret data. In simple terms, it transforms raw numbers into meaningful insights. For example, researchers might use statistics to evaluate scientific observation, predict outcomes, or simply make sense of a dataset. In any statistical study, it's important to define the units of analysis. This refers to the what or who we are studying. It could be individuals, groups, or even entire populations. Units of analysis usually are on the left of the column, and variables are on top each column there. There's also descriptive and inferential statistics, which is population and sample. We will talk about it a bit later. Now we will talk about quantitative and qualitative variables. Quantitative variables deal with numbers, things you can measure or count, like height, weight, or exam scores. Qualitative variables, on the other hand, describe categories or qualities, like eye color, academic major, or emotions. Variables can also be continuous and discrete. Continuous variable, measured along a continuum at any place beyond the decimal point, thus can be measured in fractional units, and discrete variable measured in whole units or categories that are not disturbed along a continuum. Let's talk also about nominal categories without a meaningful order, like eye colors, ordinal categories with a meaningful order, like t-shirt sizes, small, medium, and large, interval, numeric scales where the difference between values is equal, but zero is arbitrary, like Celsius or temperature, and ratio similar to interval, but has an absolute zero. And in the chart here, you can see their differences. Measures of central tendency. Now let's talk about measures of central tendency. The statistical tools we use to find the average or typical value in a dataset. Mode, the most frequent value in a dataset. Median, the middle value when data is ordered numerically. And mean, the sum of all values divided by the number of values, also known as average. Mean is also will be in our formula sheets as M. You can see here, the arithmetic mean, commonly referred to as simply the mean, is calculated by dividing the sum of the scores by the total number of observations. You can see population mean and sample mean. Also, population size, the number of individuals who constitute an entire group of population, represented by capital N, and sample size, the number of individuals constitute a subset of those selected from a larger population, represented by a lowercase n. We will also talk about a few more things before we go on. Its frequency distributions help get an overview of the data by grouping observations with identical scores together, and can give us an idea of the shape of a distribution, as well as identify potential outliers. Measures of center attempt to identify a typical or average score of the distribution. Measures of spread provide information about whenever scores are clustered close together or whenever they're spread out. And measures of location tell us where in the distribution a score is located. This helps us determine how scores should be evaluated compared to other scores in the distribution. Understanding the spread of data is crucial. Here's how we measure variability. Range, the difference between the maximum and minimum values. Interquartile range focuses on the middle 50% of the data, making it resistant to outliers. Variance, the average squared deviation from the mean. And standard deviation, the square root of variance. This tells us how much data typically deviates from the mean. We'll talk further about these things later. But now let's learn a few more terms. When analyzing data, we often measure how much each value deviates from a mean. By squaring these deviations and summing them up, we get the sum of squares, a key step in calculating variance and standard deviation. To understand the relationship between two variables, we measure covariance. Indicates the direction of a relationship. If both variables move in the same direction, covariance is positive. Pearson's correlation coefficient, a standardized measure that ranges from -1 to +1, it tells us how strongly two variables are related, and we will see that a bit later too. But now let's talk more about formulas and different things. The quartiles split a data set in 4 equal parts, each containing 25% of the data. The lower quartile, the median value of the lower half of a data set, at the 25th percentile of a distribution. The median quartile is the median of the whole data and is 50% of the distribution. And the upper quartile is 75% of distribution. How to locate each quartile? First of all, locate the median of all data. This is the median quartile, or Q2. Locate the median for scores below Q2. This is a lower quartile, Q1. And locate the median for scores above Q2. This is the upper quartile, Q3. The interquartile range is the difference between the first quartile and the third quartile of a distribution. And the formula for it is Q3 minus Q1. Variance, a measure of variability for the average square distance that scores deviate from the mean. The value of variance can be 0, there is no variability, or greater than 0. Population variance, a measure of variability for the average square distance that scores in a population deviate from the mean. Computed only when all scores in a given population are recorded, and deviation, the difference of each score for its mean. Here you can see the formula for it. We can also look at definition of the sum of squares, which we talked before, and this is the formula. The little e symbol, as you already learned before, is show that all the following sample scores should be added up, and you can see the solution a bit lower in the document, so you are able to actually do this. And sample variance, a measure of variability for the average square distance that scores in a sample deviate from the mean. This is a way to count it. We can also see its use here, and a bit more formulas. Then let's talk about deviation. The population standard deviation, a measure of variability for the average distance that scores in a population deviate from the mean. The sample standard deviation, there's an empirical rule, states that for data that are normally distributed, at least 99% of data lie within 3 standard deviation of the mean, 95 of data lie within 2 standard deviation, and 70 of data lie within 1 standard deviation of the mean. Chebyshev's theorem defines the percentage of data from any distribution that will be contained within any number of standard deviation, where SD is more than 1. Characteristics of the standard deviation is always positive. The standard deviation is used to describe quantitative data. The standard deviation is most informative when reported with a mean, and the value of the standard deviation is affected by the value of each score in distribution. Now, correlation, a statistical procedure used to describe the strength and direction of the linear relationship between 2 factors. Can be used to describe the pattern of data points for the value of 2 factors. Can be used to determine whenever the pattern observed in a sample is also present in the population from which the sample was selected. Correlational method, to treat each factor like a dependent variable and measure the relationship between each pair of variables. A positive correlation is a positive value of R that indicates the values of 2 factors. This is a few formulas for it. This is the formula for R, Pearson's correlation coefficient, a measure of the direction of strength of the linear relationship of 2 factors in which the data for both factors are measured on an interval or ratio scale. And actually, this is it. Everything else you can find in Soviso, and these are all the formulas that we've been using for now and that we might need in the closest times. Thank you for listening. I hope you enjoyed it, and I hope it made some things clearer. So yeah, see you.